For this last problem, we just need to come up with a few functions and then graph them. Notice I didn't give you a big grid, XY grid, so you don't have to be too precise on this one. Okay? You don't have to label every point on the graph, you know, it's just kind of going to be a vague graph. You'll see what I mean in just a minute. The Jones Company manufactures its products at a cost of $5 per unit and sells them for $9 per unit. That's good. They sell them for more than they cost. The firm's fixed cost is $600 a month. Determine the company's cost function, revenue function, profit function, break-even point, and then we'll graph all those functions, or at least the cost and revenue function below, which should be really easy. Okay, well, all we need to do, there's really not much work. The revenue function, R of X, how much do you sell them for? Because remember, revenue is the money coming in. They sell for $9 per unit. The revenue function is just 9 times X. That tells you how much money is coming in. If you sell 100, if X is 100, you bring in 9 times 100, or 900. The cost function, C of X, is equal to, well, how much do they pay, how much does it cost per item to make them? Its cost is $5, but you have to add in the fixed cost. Remember what the fixed cost is. It didn't say here, but it's typically like rent for the building, insurance for the building. So even if you don't sell anything, you have those expenses every single month. The profit function is P of X is R of X minus C of X. It's the money coming in minus the money going out. That's your profit. So R of X is 9X minus, and put it in parentheses, the cost function is 5X plus 600. So if we simplify that, we get 9X minus 5X, which is 4X. And this minus sign gets distributed through, so it's really a minus 600. So the profit function is 4X minus 600. Oops, let me write. P of X is equal to 4X minus 600. Sorry about that. I should have squeezed that in there. The break-even point, that's the, it's not going to be very difficult at all. The break-even point is the number for X, the value of X, where the revenue is equal to the cost. And actually, there's even an easier way. It actually takes the same number of brain cells. But the break-even point is where R of X equals C of X. Well, what would happen if R of X was equal to C of X right here? R of X minus C of X. If they're equal, what do you get? 0. So that says the profit equals 0. That's your break-even point. We can say or P of X equals 0. You'll get the same value, and you're using the same brain cells. You're doing the same arithmetic. Notice, I'll write them down both maybe. R of X is 9X equals C of X is 5X plus 600. Solve that for X, and you get the break-even quantity, the break-even number that we're looking for. Break-even point usually implies an XY pair, which we'll write down. It means the X, and it also wants basically X, comma, Y. I'll say it that way. But notice what P of X is. P of X is 4X minus 600. If we set that equal to 0, it should be easy to see that these two things I'm putting the blocks around here, they're equivalent. If I were to subtract 5X from both sides, I get 4X equals 600. And if I added 600 here, I'd get 4X equals 600. Okay, so let's just solve either one of them. You'll get the same answer. This means that 4X is equal to 600. And if you divide both by 4, you get X equals, half of that would be 300 and half of that would be 150. 150 times 4 gives you 600. So the break-even point, the break-even quantity is good enough. So we didn't actually do the break-even point. This is the x value of the break-even point. What you would do then is plug x into either one of these functions, you'll get the same thing. If you plug in 150, you would get r of x is 9 times 150, which is 1350. That's really the break-even point. And notice if you plug it in here as well, since it's a break-even point, if you'd bring in $1,350 in revenue, your output is also going to be your outgo, your cost would be $1,350 as well. If you plug in 150 in this function, you'll get 5 times 150, which is 750, plus 600, which is 1350. So basically, I'm most interested in the x value of that break-even point, that number 150. So maybe I could have said the break-even quantity, because x is the quantity. And in that case, it would have been very clear that only 150 is the number that I'm looking for. So just to repeat that, the break-even point is if you produce and sell 150 items, your profit is going to be 0. What is this number? Well, if you produce and sell 150 items, it's going to cost you $1,350, but you're also going to have $1,350 in revenue coming in, which gives you your 0 profit for your break-even point. All right, on this graph, I don't want to be too picky, and it's not very difficult. The cost function and revenue function. Well, the revenue function is simply r of x equals 9x. And I'm not going to be very picky. I'm not going to make the slope equal to 9 because that would be way too steep. I'm just going to do it something like this. Let's say that's r of x equals 9x. The slope is 9, y-intercept is 0. Well, the cost function is a little bit different. It has a y-intercept. The y-intercept is 600, which I'm just going to put that right here, 600. And the slope of the cost function, is 5x. The point being, it's a smaller slope than the revenue. It's not going to be as steep as this function, which means it's going to cross somewhere, like that. That's our profit function, which was, our cost function, which was 5x plus 600. And this point right there where they cross, that's the break-even point. That would be, what was break-even point? The x value is 150. And the height of the function at this point is actually 1350. So you can see I'm a little bit off. If I drew this line across, it doesn't look like it would be 1350 because I wasn't concentrating on getting precisely the slopes of these functions. So that's really all I expect. The revenue function starts here at 0 because the y-intercept is 0 of the revenue function, plus 0. The cost function has a y-intercept of 600, but the slope is flatter. It's smaller than the slope of the revenue function, so it will cross it, just like that. So one final comment on this. This graph shows well that if you produce and sell fewer than 150, let's say this number right here, this is how much revenue you bring in, but this is how much your costs are. You're losing money here. But once you get beyond this point, the revenue function is higher than the cost function. So say, for example, at this point, here's how much your costs were, but your revenues exceeded them. They're much higher. So here you're making money.